Hello and welcome to AP Test Review. Today we're going to discuss conditional probabilities and modeling certain scenarios with tree diagrams. Now I'm going to break probability into probably three different reviews. This one I picked to do first because generally it's on the AP test. It's in some kind of form similar to what we're going to discuss today as question number 3. Question number 3 also correlates very strongly with students that pass the AP test. This year is unusual, 2020, so we're only going to have 2 questions, and I'm willing to bet there's a high probability that this is going to be the 15-minute question. Just my opinion, but I definitely think there's a strong chance it'll be either question 1 or question 2. If I was to guess, question 1 is going to be multiple aspects of the stats we've learned this year. I think it's probably going to be a stat test mixed with a little experimental design and maybe some descriptive statistics as well. But again, that's just my educated guess. But again, this question correlates very strongly with students, this type of question correlates very strongly with students that pass the AP test with a 3, 4, or 5. So let's start off with our essential vocabulary. First, what are conditional probabilities? It's the probability of an event occurring given that we have knowledge that some other event has occurred before or first. So that's what a conditional probability is. Tree diagrams. Well, let's go back to conditional probabilities. There's some context clues that tell you you're dealing with a conditional probability. If you see the wording given that implies there's a condition, and also kind of an if, then. If this happens, what's the probability that this then will happen? So those are both context clues that tell you that you're probably dealing with calculating a conditional probability. Now, tree diagrams are great for modeling conditional probabilities, and they're good for modeling sequential events. Now, just because some students have a hard time wrapping their head around this doesn't necessarily have to happen first and that they run into roadblocks. It's not necessarily that a specific event has to happen first. It's just knowledge of that event happening has already occurred. So don't always think of it that it would have to happen first. It's just knowledge of some other event, the probability that that event occurs. We have knowledge of that. Then what's the probability that this secondary event happens? And tree diagrams are a great way to model sequential events or knowledge of another event happening before a secondary one occurs. Okay, roughly 2.1% of the U.S. population has red hair. Of those with red hair, approximately 20% have green eyes. Of the U.S., so here's another context clue. This is telling me it's conditional of those with red hair. So the condition is that they have red hair. So the people that have red hair, 20% of them then have green eyes. So I have knowledge of the fact that this person has red hair, then there's a 20% chance they also have green eyes. Of the U.S. population who do not have red hair, so there's that knowledge, 2% have green eyes. So what I have knowledge of first is whether or not a person has red hair. So I'm going to draw myself a little stick figure representing a randomly selected person in the U.S. population. The probability they have red hair is 2.1%. Now the other option is that they don't have red hair. So that's my first event, knowledge of having red hair or not. So 1 minus 0.021 is going to give me 0.979. So the branches of the first series have to add up to 100%. Now, having knowledge of whether or not a person has red hair, they could also have green eyes, or they don't have green eyes. So G and G prime. So when you're using letters to represent variables, it's always good to define them. So event R is having red hair. Event G is having green eyes. And you'll hear me say G prime This is the complement, so green, not green. All right, so you could have red hair and have green eyes, or you don't have green eyes. Okay, so of those with red hair, so I'm following this red hair branch, 20% have green eyes. So this series of branches right here have to add up to 100%. So the complement of having green eyes is not having green eyes, and that's 80%. And then of those who do not have red hair, oops, forgot my prime there, so not red hair, 2% have green eyes. That means 98% do not. Now, I have my first event, which is knowledge of having red hair or not, and then my secondary event, whether or not they have green eyes. This probability right here is a conditional probability. It's the probability that someone has green eyes given that they have red hair. That's 20%. So then so these are all conditional probabilities right here. So this one, if I had to write it symbolically, this is a probability that someone does not have green eyes given that they have red hair. And same with down here. So these are all conditional probabilities. So when you're calculating, well, we'll get into that here in a minute. I would recommend that you also carry on and find the probability that both events occur. Probability that R and G, person has red hair and green eyes. And that can be found by multiplying 0.021 times 0.2. And that's going to equal 0.0042. All right. Then I'm going to find the probability that a person has red hair and does not have green eyes. And that's going to be 0.021 times 0.80, which is 0.0168. And I'm going to find the probability that someone does not have red hair and has green eyes. And that's going to be 0.979 times 0.02, which is 0.01958. And then I'm going to find the probability that someone does not have red hair and does not have green eyes. And that's going to be 0.95942. Now these should all add up to 100, or 1.0. All right, now I've got it set up so where no matter what kind of question they ask me, I have all the tools necessary to quickly calculate a probability question based on this scenario. Okay, so let's answer some questions. Let's talk about this. Okay, on the AP test, you're going to be given a pretty extensive formula sheet. Today in this lesson, we'll be using our conditional probability formula. So probability and distributions, so we're going to be using this one right here. Let's talk a little bit about that formula. Because it's symbolic, this means the probability that A happens, given that B has already occurred, or knowledge of B, we have knowledge of B. So then I like to simplify this a little bit. I want to think of it in terms of what it really means. It's the probability that both events happen over the condition. Just simplistic way of thinking about it. And then also when you're seeing this symbol here, and we'll talk about this one in this union symbol here in a different lesson, but this is the intersection. What that means, A and B, where both A and B occur. Both A and B occur. So that's the symbol here. Think of it in terms of and, or both occur. And then this is one or the other. Think of it in terms of or. And this is also usually, well, it's a multiplication rule, and this one's the addition rule. All right. So we'll be using this formula today. So just think of it as both events occurring, the probability they both occur over the condition. All right, what is the probability that a randomly selected person from the US does not have red hair? So that would be R prime. And, there we go, and does not have green eyes. So R prime and G prime. Now if I go back, I think I've already calculated that. I've already done a lot of the legwork. So I need to look for R prime and G prime. There it is, that last one right here. R prime and G prime, 0.95942. So I've already done that work. All right. Okay, here we go. Given that tells me right away, context clue. This is going to be a conditional probability, and the condition comes after that phrase, given that. So what I like to do, so I write these, so I'm going to come back to the condition in a second. I'm going to go to the part of the sentence that says, what is the probability that a person has green eyes, given that the randomly selected person from the US does not have red hair? So R prime there, because we write it in that order. I want to think about it in that order. Now if I go back up to my formula sheet, so just think of G is in place of A and R prime is in place of B, so it's the probability of both over the condition. It's going to be a probability of G and R prime over R prime. Okay, so I go back to G and R prime. G and R prime, there it is right here. Can be in it, it doesn't matter which order it's in, so it's 0.01958, and then R prime is 0.979. So I have all the pieces I need already calculated for me. I divide those and I get 0.02, so there's a 2% chance that, given the knowledge they have, do not have red hair, the probability they have green eyes. All right. Given that a person from the US does not have green eyes, okay, so now again, I see there's a condition. I have knowledge of their eye color. But remember, again, I want to write this in order, so I'm going to skip to the phrase, what is the probability? So what is the probability that they do not have red hair? So R prime, given that I have knowledge that they do not have green eyes. So again, it's the probability of both, so R prime and G prime over the probability of G prime. All right, again, so R prime and G prime is going to be 0.95942, and I'm going to have to do a little bit of work for probability of G prime. That could be done two different ways. I could have red hair and not green eyes, and I can have not red hair and not green eyes. So I have to add these two together to account for all of the possibilities of G prime, or not green eyes. So let's see. It's going to be 0.95942. And then two different ways to not have green eyes, with red hair and without. So I'm going to add those two together. And that, if you think about that, that makes sense, 98%, because most people don't have green eyes and most people do not have red hair. So, you know, if you always want to think of your answers as, does that seem reasonable? Is that a reasonable answer? And it does seem reasonable. All right. What is the probability of randomly selecting a person from the US that has green eyes? So I'm just looking for the probability of having green eyes. Again, this can happen two different ways. They either have red hair or they don't. So I want the probability that they have red hair and green eyes, which and plus the probability they don't have red hair and have green eyes. So there's two ways to have green eyes, with or without red hair. And if I go to my tree diagram, I can pull both of those from those probabilities I calculated. It's 0.0042 plus 0.01958. All right, add those two together, and I get 0.02378. Okay, here we go again. Given that a randomly selected person in the U.S. does not have green eyes, so I know I have a condition. I have knowledge that they do not have green eyes. So I'm going to skip to, what is the probability that they have red hair? So red hair, given that they do, does have green eyes, sorry. So it's a probability of both, so red hair and green eyes, over the probability of green eyes. All right, again, pull these from my tree diagram. And then green eyes, again, members, it happens at two different ways. I just found it up here in part D. Probability of green eyes is 0.02378. Divide, and I get 17.66% chance. All right. Assuming that the population in the U.S. is very large, which it is, what is the probability of randomly selecting 15 people from the U.S. and at least 2 of them have green eyes? This is a little different. Now I all of a sudden have a sample size, and I want to find the probability of selecting at least 2 of them with green eyes. So I'm going to set x equal to the number of people who have green eyes. This smells a bit like a binomial problem. Number of people who have green eyes. This might be a binomial setting. So let's think about it. For a scenario to have a binomial setting, it needs to be binary, and that would be green eyes or not green eyes. So that checks. Independent. Well, I am sampling from a finite population without replacement, but that population is very, very large. So selecting 15 people, that the probability of selecting another person with green eyes, given that you selected the first person with green eyes, that probability wouldn't, that'd be very insignificant, be very small. So I can assume a level of independence because of the population being so large. My sample size is 15. And my probability of success, what's the probability somebody has green eyes? I believe we calculated that. It's right up above, 0.02378. So I've met the requirements for a scenario to be binomial. All right, so I'm going to use technology. This is, I want the probability that at least 2 of them have green eyes. So that could be 2, 3, 4, 5, all the way up to 15 out of 15 have green eyes. This is a binomial CDF problem. Depending on what calculator you have, I use the TI Inspire. So I'll show you what, actually, most of you aren't using that. So you would find the binomial CDF function on your calculator. Label your inputs. You have to label your inputs on the AP test. Otherwise, this is considered calculator talk, and you probably won't receive credit for it. So your sample size is 15. Your probability of success. I have a lower bound. So my lowest number that satisfies this is 2, at least 2, and my upper bound. And the way to do binomial CDF might be different for your calculator. You'll just have to find out how to enter this in. I could have all the way up to 15 out of 15 successes. And I'm going to get probability of 0.04836. So the probability that at least 2 out of 15 have green eyes. There's about almost 5% chance. All right. So that takes us to the conclusion of this quick review on conditional probabilities and setting up scenarios using tree diagrams. Again, the third question on the past FRQ test is almost always a probability question, and almost always there's some conditional probability to calculate. So look up the past tests and practice these skills that you've just acquired or have reviewed and brushed up on. Where can you find these FRQs? If you go to the College Board site, all FRQs going all the way back to 1996 when this test was first administered are available to you, as well as the rubrics. So I encourage you to go back. Last year, question 3, 2018, 2017, they were all very similar in structure to what we just went over. I would try those and then go ahead and score it with the college rubric. And again, I'm pretty confident that we'll see some sort of question similar to what we just covered on the 2020 test that's been shortened down to 2 questions. And if you're a teacher and you like this video, visit my store. I sell a whole AP Stats curriculum as well as the statistics curriculum as well. All right, thank you for joining me, and I will see you at the next review.